Now we will learn application of total internal reflection through right angle isosceles prism. All these prisms what we have considered is made up of glass, and for glass remember critical angle ka value will be 42 degree. So this is isosceles right angle prism. So this angle must be 90. This is 45. This is 45 again 90, 45, 45, 45, 45 and then 90. And using these prisms we have got three applications where we can deviate a ray of light by 90 degree or by 180 degree, or we can use it to obtain inverted image of an object. So whenever a ray of light traveling from optically denser to optically rarer, remember four important conditions are there. Remember, if angle of incidence is 0, angle of refraction will be 0, it goes undeviated, remember, while traveling from denser to rarer. This is the first case. Second case explains that if angle is less than critical, so what happens over there? There happens refraction occurs. That means the ray will get refracted into the rarer medium. Third, if angle is equal to critical, what you have to say? Grazing emergence will occur. And grazing emergence, you can say that angle of refractions become 90. And the last case, if angle of incidence is more than critical, then only total internal reflection takes place. So these four conditions is very important to study the total internal reflection through prisms. So let's consider the first case where we have to deviate a ray of light by 90 degree. Now I will consider a ray is incident normal to the surface. So this is the incident ray, and you can see it is incident normal to surface. So when it is incident normal to surface, so this is the first case I am talking about where angle of incidence is 0. So the angle of refraction will be 0, and we say ray goes, come on tell me, undeviated. So this is applicable whether the ray travels from rarer to denser or denser to rarer. So I will continue this ray and I will continue this ray, and now this ray is trying to travel from denser to rarer, and then we have got an interface. So what I will be doing, I will be drawing normal at this point and measuring certain angles, because based on the value of angle of incidence we would be able to identify whether it is first case, second case, third case or the fourth case. So see the geometry. If it is 90, it is 45. This angle has to be 45. This angle has to be 45. So this angle will also be equal to 45 degree. Now remember, angle of incidence is the ray angle made by the incident ray with respect to normal. Here this ray was going from glass to air at an angle greater than 45. So whenever a ray traveling from glass to air at an angle greater than 45, that means for glass the critical angle is 42 degree. So definitely here this angle is more than IC. This angle is more than IC. I can say that, let's say this is point A, this is point B for reference. At A you can say I0, R0, you can say at B. What happens? I is more than IC. So what will happen over there? Total internal reflection. And now when ray is incident by 45 degree, it gets reflected by 45 degree. So this has to be 45. Remember, this is 45, so this also becomes 45. This was already 45, so it has to be 90. And then at point C we can say, at C I is 0, so R is 0, and the ray goes undeviated, so we have got the emergent ray. So overall we can say that this ray has deviated by 90 degree. The ray has been deviated by 90 degree by a prism. That means this was the incident ray, These were the two refracted, this was the refracted ray, this was the reflected ray, and this is the emergent ray. So finally we can see that if a ray is incident on one of the surface or one of the sides of the isosceles right angle triangle, normally definitely it's gonna reflected or it's gonna deviated by 90 degree. If you draw another ray, let's draw another ray parallel to this, so definitely no need to measure all this angle, right? So you can simply draw that if this was AB, then it has to be, come on tell me, A dash B dash. In the second case, we have to deviate a ray of light by 180 degree. So make sure in this case the ray should incident on the hypotenuse. It should incident on the hypotenuse, and how it should incident normal to the hypotenuse. So let me draw the incident ray in this case. So if I draw incident ray normal to the surface, definitely again I would name it at point A, and again at point A, what is the angle of incidence? Come on tell me. 0. The angle of refraction has to be 0. So it goes undeviated, and I will continue the ray. Again it meet at B. Now it is trying to go from denser to rarer. So again we have to see the conditions by the geometry. Let me draw the normal first. Remember, the normal should look like normal because it's gonna give you the value of angle of incidence. So this is 90, this is 45, this is 45. So this has to be 45. So here, can I say in this case at B, what happens at B over here? I is equal to 45, which is more than critical, So definitely what will take place? Total internal reflection will take place. So definitely the ray will get reflected by 45 degree and hit the surface. Now again at C, it is trying to go from denser to rarer. So at B, total internal reflection will take place. This is 45, so this is 45, this is 45, this is 90. So this has to be 45. If I draw normal on this surface, the angle of incidence will again be 45 degree. That means again at B and C, the angle of incidence is 45, and in both the case the ray is traveling from denser to rarer. So while traveling from denser to rarer, if angle is 45, which is more than critical, what will take place? Total internal reflection will take place. Again the ray will get reflected by 45 degree. So this is the reflected ray, and if you measure it, it is 45, this is 45, this was already 45, so it has to be 90. So what happens at point D? Come on tell me. There is a normal incidence first case, so the ray goes undeviated. Overall you can say the ray was traveling towards the right direction, then after suffering two total internal reflection by 90 degree, it is traveling towards the left direction. That means the deviation over here is 180 degree. If I draw another ray simultaneously, it would be something like this. You need to draw the arrow in each case. Got it? So to obtain the inverted image, there is a simple rule. You have to draw certain rays, you have to incident on them, you have to totally internal reflect them, and then get the inverted image. No need to measure over here, but I'll tell you a method how to get the inverted image of the same size. What you do, whatever size of the prism is there, hypotenuse, just divide it into 3 equal sections. Consider one of the ray traveling parallel to base, remember, okay, and make this ray, okay, let this ray be incident at this point. Definitely other ray which was traveling parallel, after refraction will meet at this point. Consider both the rays to be parallel. So this was the object, let's say this was the object AB, and now here on this surface refraction of light has taken place, but here by angle measurement definitely total internal reflection will take place and the ray will get refracted. So here you have to consider 2 points. in the exact directions of the two incident rays. So remember, join this point with this one and then refract it, this point, this one, and then refract it. Got it? So this ray A is now present at the bottom point B is now present at the top. We can say this is B dash, A dash. So what we can see, we have obtained the inverted image. Thank you.